Again, welcome to Python course. In this lectures, we're going to study about selection statements. That's how a program can make a decisions. In almost every programming language, we have three major control structures from Java, C++, C, Basic, Visual Basic, etc. Every programming language have three control structures. The three control structures are sequence, selection, and repetition. Sequence is a built-in, which means every time a programming language execution starts from top down in sequential order, from top down. So it's a built-in already for us. In our previous lectures, we wrote a program whereby we find a sum of two numbers, or we find an interest of a loan. It's a sequence. What we did is that we get our input, then we process our input, then we display our result in sequential order from top down. Now, in selection statement, which we are going to start today, we are going to learn how we can write a program to tell the program to make a specific decision. Most programming language decisions are logical, either true or false. So here in Python, we have few selection statements that we can write for us to, again, make a program to make a logical decisions. And we will see some few programs along the way. So in our main objective here, we're going to learn what is a Boolean expression using relational operators. In order to make a logical statement decisions, we need relational operators, like example, greater than, less than. If 10 is less than 20, do something. If the value in a variable name x is greater than 100, then do something. These are selection again statements, making the logical decisions. So we're going to learn how to use these built-in functions, that is the random, randint, randrange, and randomos functions. We're also going to learn how to implement a selection control using one-way if statement, then also using the two-way if-else. If statement, we only have the condition if it's true. We're going to again execute some statement. With if-else, if it's true, we do something else. If the condition is false, we do different things. So that's why we call it two-way if-else. We have statement or expression for both when the condition is true and when the condition is false. Also, we're going to learn how to implement selection control with nested if and also multi-way if-elif-else. This means we have more than two statements. So let's say example would be grading system. We know students, when they get score between 90 to 100, we give them A. From 80 to 89, B. From 70 to 79, C, etc. So this means I can't use a two-way because it's only if and else. It's true or false. But in this case, I can use the multi if elif-else. This means I can have as many, actually that's why we call it multi-way. I can have as many selection statements, many conditions as I want. Also, we're going to learn how to program with selection statements. So in these lectures, we have around 4 to 5 examples of Python programs where we are using the selection statements. So let's start with the Boolean data types. We know almost every programming language have a Boolean data type. A Boolean data type will take only two expressions or two items, true or false. Like in C++, 1 means true, 0 means false. In Java, we use the word true or false. So in Python, the same thing. A Boolean data type will take either true or false values. So Boolean values can be true or false. So here we say often in a program, you need to compare two values, such as whether I is greater than J. Now we have 6 comparison operators known as relational operators that can be used to compare two values. Always the result of the comparison will be a Boolean variable, true or false. So here we have a relational operator here we are using is greater than. So here we are saying that is 1 greater than 2, our answer will be false because 1 is less than 2. Now, if we have a relational operator here less than, is 1 less than 2, the answer will be true. So as we said earlier, selection statements, the outcome is only true or false. And that's why we use the term logical expression. So logical expression means we have only 2 outcomes, true or false. So these are the relational operators for Python program. It's almost exactly the same as Java, C++, and most programming languages. So that's the symbol for less than. We use this also in arithmetic operations. Then we have less than or equal. We have greater than or equal. Now in Python, 2 equal sign means we are checking is equal to. 1 equal sign means assignment. So for example, if I have x with 1 equal sign 10, it means I'm assigning 10 to x. But if I have x equal 10, it means I'm checking if the content of x is 10. So that's the difference. Same thing applies to Java programs, C++. 2 equal sign means we are checking the equality. 1 equal sign means assignment operator. We are assigning the value on the right side to the variable on the left side. We also have not equal. Now, not equal, equal, greater than or equal, less than or equal. When you are writing them, there's no space between. So less than or equal will be left arrow and then the equal sign, no space between. The same thing applies to greater than or equal, no space between. Right, type the right arrow, then the equal sign. So these are again the relational operators we have. Again, less than or equal, greater than or equal, equality or not equal. So again, we can use these relational operators now to almost write any condition, to test any expression conditions. So we are giving an example here. Here they say this example will create a program to let a first grader practice additions. So the program randomly generates 2 single-digit integers, number 1 and 2, and it will display a question such as, what is 7 plus 9 to the student. Now, after the student types the answer, the program will display the message to indicating whether the answer is true or false. So you can see that here we have to use the relational operators. Why? We randomly generate 2 numbers in this program. Then we ask the user, for example, 7 plus 9 is what? Maybe the user says 7 plus 9 is 10. Then we're going to display a message that that answer is false. So which means we have to have a condition that will test the actual answer with the answer that the user gave. If both of them are the same, then it's true. If they are not the same, then it's false. So let's see how this program works. Going to click on addition quiz. So that will take us to the program. Let me see if I can increase the size. Yeah, I want to zoom it to increase the size of the program. I think this is good. Okay, so here we can see now, first thing, we have our input. So we use the random class. Here we are generating a random value. So we're using the randint method to generate any value 0, 9. So generating any value between 0 to 9, 0 to 9. Now when we generate the number, we assign the number to a variable named num1. We generate the second number. We assign the number again to variable num2. So this will be our 2 inputs. Again, we are using the random class to generate random values. Now the values I want to generate is an integer value, so I use the method randint, and I want to generate numbers between 0 to 9. Now in order to use the random class, We also need to import the random package. So here, import random, then we use it. So we generate the two numbers here now. The next step, we are going to ask so prompt the user to enter an answer. So here we say, what is, our first value is num1, plus our second value is num2. Now, why do we have this string here, str? If we remember the previous lectures, we said that anytime we use the method input to get input from a user, that input will be a string type. So we need if we're going to use the input for multiplication, addition, any arithmetic expression, then we need to change it to either float or int. And that's what we are doing here. Here we ask the user what is the number. By this time, this number is an int. We use the run it to generate the number. So we change this to str. The reason why we change it to string, because the input function, the argument, the value have to be string. So we say what is the number 1, which we have, plus the number 2. We have a question mark. So next, we are going to print. So here we are, again, the input here allow the user to input. We are using the input method to allow the user to enter the input. To allow the user to enter the input. So what the user is going to have input is that this value plus the second value is what? The answer is here. Here we are not doing no arithmetic operation. That's why we said here, prompt the user to enter an answer. This is just a sentences. Everything here, actually you can see that we change the num1 to string. So this is everything a string here. Then the user will enter the input. The input will go to the variable name answer. Now we want to check if the actual answer with the answer that the user provided as input, they are the same. So we're going to display the results. We want to print num1, which we have already, plus num2 is equal to the answer. It's equal to the answer. That's the answer that the user enter. Is num1 plus num. Now this is the actual answer for this is what the user enter here as the answer in the variable answer. Now this is the correct answer. Is it num1 plus num2 equal to the answer? So now we're using the equality sign here to check if the user enter. Again, as I said earlier, this expression here, we are not adding no value, it's just the instruction for the user. So we're telling the user, we generate two numbers. We're telling the user, is when you have the two numbers, what is the answer? The user enter the answer here. Again, why we are using the str, which is a string, because we are using the input function. Remember, input function, the value that it gets or arguments always in strings. So that's why we make it string, because it's the argument of the input function. So when we get the string, we can see that we are using the input. After the input, we are using the int method here to convert what? The answer that the user enters as a string, we are going to convert into int, because we need to use the relational operator to compare if the actual num1 plus num2 is the same as the user. So this is what we are doing now. So this will give us two options. Either the answer is true or false. So if the user enter the right answer, then it's true. Otherwise, it's false. Let's run this program. Again, one more time. We are importing the random because we want to use the run it to generate a random input, two integer values, to num1 and num2. The numbers will be from 0 to 9. Then we tell the user that, okay, the two numbers that we generate, when you add them, so here we're using the input because we want to get the answer from the user. So we say input function, what is num1 plus num2 with a question mark, what it is. The user will enter it, then we convert, again, we are using input method. So the input will be in, again, strings. We use the int method to convert it to integer. Then we assign whatever the user enter to a variable answer. Then here we are going to again add the two actual values. So num1 plus num2, whatever the answer is, we are going to compare it with what the user enter. So in our output, we will see the num1 value, then plus, then we see the num2 value, then equal what the user enter. Then we say is the actual answer now, num1 plus num2 equal to the answer. So here we are going to get only two options. The output will be true or false. So our output will be, let's say I enter 7. 7 plus 2 equal to 10 is false because 7 plus 2 give me 9. So let's see this program. So again, let me zoom it. So that's the answer here. So you can see that here, what is 1 plus 6? The user enter 8. So now we say 1 plus 6 equal to 8 is false. Is false. So that's what we have here. Let's say 8 plus 2 equal to 20 is false. So again, this will be our first example, how to use the relational operators. So this program is making a decision here for us, whether the number we enter is true or false. So let's continue. So again, in Python, we have, as we said earlier in the objective, we have one-way if statement, then we have two-way if-else, then we have a multi-way, that is if it's more than 2. So we start with the syntax for one-way if statement. So one-way if statement, we use the if lowercase if is again a keyword. If I want to use an if statement, I'll use if lower cases, then my condition, the Boolean expression. Then if the condition is true, what will be executed? Again, in our previous lectures, we said in Python, we don't use parentheses in a block statement. We use an indent to indent. So the statement here affects only the Boolean expression. Now, if I move this statement to this align with the if, then the Boolean expression does not affect the statement. So that's again the syntax. And we can see the flow diagram. We are coming sequential order from up. We test our condition Boolean expression. If it's true, we execute our statement and we continue. Now, if it's false, we cannot execute this statement. So we move and continue. So we skip the statement. So the statement will execute only if the condition is false. Then we can see an example here. Here they say if a radius is greater than or equal to 0, at least greater than or equal to 0, which means we don't want radius to be a negative value. Then we can do our area for the circle. So the area will be radius times par, which is 3.14159. Then we print, this is our output, we print the area for the circle of radius, which was given is the area. So we're going to enter the radius already at the top somewhere. This is just the if selection area. So let's say we use input method to get the input from the user. The user entered the radius to be 0.5. Yes, is 0.5 greater than or equal to 0? Yes. Then it will be 0.5 times 0.5 times 3.14159. Then the solution, we are going to print our output. So we print a string saying that the area for the circle of radius is, this is a string, double quotation. The content of the area value here, we are going to print it here. and the radius that we enter will be here. So 0.5 is whatever answer we get. Then again, we should pay attention. I'll always repeat this because if we have taken C++, Java, etc., we always have our the body of the function will be inside the curly brace parentheses. In Python, we have to indentation. So we indent it once, we can see that all the code here, these two code belongs to if statement. If it's true, everything here will execute. And we can see the diagram here. We say, okay, if the radius is greater than or equal to 0, then do your calculation. Find the area of the circle and print the result. If it's negative value, then we cannot find the area of a negative value of a radius. So let's say, for example, user enter -10. Is -10 greater than or equal to 0? No, false. So we skip all this and we continue with the program. So this is a note again. This is about indentation. So here you can see that we'll say if I greater than 0, remember again we did in the previous slide, we have to have a colon at the. So here we say that if I greater than 0 colon, print I is positive. This is wrong. Why? Because the if statement does not have any effect on the print state. Its syntax, if I run this program, there will be no error. The only thing is that the print will always execute. Always will say I is positive, will print out. Why? Because the print method here doesn't affect the if statement because they are all aligned in the same alignment. We have to indent it. So this is correct way. If I greater than 0, print I is positive. So if I is 20, it will print positive. If I is -10, it will not print. By here, whether I is negative, I can be any value, it doesn't matter. Always the print I is positive will print because the condition here does not affect the print statement. It doesn't affect it. Here, the condition affects it. We indent once. So we have another demo example here. Here they say we should write a program that prompts the user to enter an integer. So the user is going to enter an integer. Integer again is a whole number. Now, if the number is a multiple of 5, then we print I5, which means the number is 5, 10, 15, 20. We multiply by 5. Now, if the value we enter, let's say, is 3, we cannot print I5 because 3 is not a number that is multiplied by 5. Now, if the number is divisible by 2, then we print I-even. So I-even means if I enter 2, 4, 6, these are even numbers. So here, we need the relational operators. We have to check the condition. So let's see how this program is written. So we ask the user, again, we use the input method and we tell the user enter an integer. Now it depends. If the user entered 10, then it's 10 modulus 5, the answer is 0. So the condition here is true. So we print I5. 10 modulus 2, the answer is still 0. So the condition is good. So when we run this program and we enter 10, we are going to print both I5 and I-even. But let's say we enter 4. If we enter 4, 4 modulus 5, the answer will be 4. So we will not print this. The condition here is false. But 4 modulus 2, the answer is 0. So we are going to print only I-even. So we know that we talked about the modulus operator a few lectures ago. Modulus operator will give us the remainder of 2 values. When we divide 2 values, the remainder of them is the modulus. So for example, if I divide 7 by 5, the remainder will be 2. So 7 modulus 2 and modulus 5 is 2. So again, let's say we ask the user now, input some value, the user input 0. 0 modulus 5, yes, 0 modulus 5 is 0. And then 0, because when you divide 0 by 5, the answer will be 0, remainder 0. And then 0 modulus 2, when you divide 0 by 2, the answer is 0, the remainder is 0. So that means if I enter 0, the printout to be I5 and I even. Now, let's say we enter 1. If I enter 1 modulus 5, the answer is not 0. If I divide 1 by 5, the answer will be 0, remainder 1. So this gives us remainder. And the same thing, if I enter 1 divided by 2, the answer will be 0, remainder 1. So if I enter 1, nothing will print. The whole concept I want us to understand is we are using a relational operator here. So when we use the input method to allow the user to enter an input, we change the value. Again, as we said earlier, when we use an input method, the value that the user enter, the data type will be string. So if we want to use the value for, let's say, relational operators, in this case, relational operators, or we want to use it for arithmetic expression like addition, subtraction, etc., then we need to convert it to either float or int. In this case, we make it int. So we store the value in a variable named number. Now we want to see if the number is multiplied by 5. So we have the modulus of 5. If the number is multiplied by 5, means the number is 5, 10, 15, 20. So if I divide 5, 15, 20, 25, 30, if I divide any number multiplied by 5, the remainder always will be 0. So that's why we are using this modulus operator and equals 0. And the same thing applies. If I enter any even number, if you divide even number by 2, you will get some answer, but the remainder always will be 0. So we check also that. So let's run it and see. So here we can see the user enter 4. So we can see that when the user enter 4, only I even print. Now let's see if we can change this value to, I was saying about 0 before, so let's see 0. So this is again using 4. It's not taking the so when we enter 14, it gives us I even, which is right because 14 is not a multiple of 5. But let's find a good number. Yeah, let's enter 10. So if I enter 10, I should get both I 5 and also I even. Yeah, so we get both I even and I 5. So again, the whole concept is looking at the program. We ask the user to enter an input. Using the input function, we change it to int. We assign to number. Now we want to see if the number that the user enter is a multiple of 5. That means it's divisible by 5. So we have to use the modulus operator. So we say the number modulus 5 equal to 0, which means anytime we divide the number by 5, the remainder should be 0. Then it's divisible by 5. We check also if it's an even number. So we know even number is always 2. When you divide any even number by 2, the remainder will be 0, and that's what we are checking here. So we can continue. So now we go to the two-way if statement. As we said earlier, we call the other one-way if statement because we have only the condition for true. But now we have if and else. If the condition is true, the first statement will execute. If the condition is false, the second statement will execute, which is else will execute. So we can see the flow diagram. We have a Boolean expression. Our condition is here. If the condition is true, then we go to the left and execute our statement. If the condition is false, then we go to the right, execute. So we have the statement to execute when the condition is false. For one-way if statement, we only have a statement to execute when the condition is true. But if else also, both true and false, we have two of them. So let's see a syntax example here. Now you can see what we are doing now. Previously, we said if radius is greater than or equal to 0, find the area and print the area value. That's it. But now we also want to give the when the condition is false, we want to print some instruction. So if the user enter a negative value, that means negative value is less than 0. This condition will be false. So since the condition is false, we print the else. So we tell the user prints the negative input. You enter negative input. Radius of a circle is an object. We don't have to use a negative. We can't get a negative radius value. Always have to be positive. So here we have both true condition and also the false. So let's see this example. Now this is the same example we did before the mathematics learning. This time we are going to prove it so that when user is true, it will print true answer. Else, if the answer they are not the same, which is false, then we give a different explanation. So here we say this example, create a program to teach a first grade child how to learn subtraction. The program randomly will generate two single-digit integers, number 1 and number 2, with number 1 greater than or equal to number 2, and display a question such as, what is 9 minus 2 to the student. After the student types the answer, the program will display the message indicating whether the answer is correct. So for example, 9 minus 2, I enter 3. So it will tell me it's wrong. And 9 minus 2, I enter 7 to tell me it's correct. And then first we have to generate the two values. So again, this is the program. Let me reduce the zoom. Okay. So here again, the first, as usual, we import the random. Then we use the random to generate two values, and the values will be int. So we are using the run int. They generate values between 0 to 9. Now we are going to test here. If num1 is less than num2, then what we're going to do, we said num1 comma num2 equal to num2, then num1. This is called simultaneous assignment, which means here we want to make sure that num2 is greater than num1. So if num1 is less than, here we want to make sure that num1 is greater than num2. So if num1 is less than num2, then we are going to swipe. So that's what we said here. If num1 is less than num2, swipe num1 with num2. So the condition means, because we want to get a positive answer, and you can see here, our arithmetic operation will be, we are having num1 minus num2, which means we are subtracting num2 from num1. We don't want to have a negative answer for now. We want to have always positive answer. So num1 always have to be greater than num2. But if the user, again here, the user is not entering the number, and the number is randomly is generated, so we don't know. Num1 can be greater than num2. Also, num2 can be greater than num1, because this is random number generation. Now, if we are asking the user to enter the numbers, we can have instruction that user enter num1, the value that is greater than num2, or the first value should be. But if we are generating the number randomly, we can tell the random method run it to generate num1 bigger value than num2. So in this case, we have a condition here saying that, okay, if num1 is less than num2, then let's swap it. So we get num1 down, then we assign num2 to num1, then num1 to num2. We said this also, I think, in the previous lectures. Now, if I'm doing Java and I want to swap two values, what I need to do is to create a third variable, then assign the first value to the third variable. then assign the second value to the first value. Then what is in the third variable, you give to the second. So you swap it by having one temporary place. By Python, make it easy for us. Python say we don't need a third variable. We can just assign it. We say we have num1 already. Then we say num2 assigned to num2, num1 here. This means we are putting num2 to num1 and num1 to num2, because here we have num1 is less than num2, but you can see we have num1, num2, assign num2, num1, which means num2 will go to num1 and num1 will go to num2. So you have num1, num2, num2, num1. This again, you cannot do this in Java. Java say, okay, have num3, put num1 to num3. Then you can take num2 to num1. Then you can take what is in num3 to num2. So you have a third variable that will hold it. But Python says, okay, I have num1 is less than num2. So I can say num1, num2, assign num2, num1. So you're giving num2 to num1, then you're giving num1 to num2. So this is a condition that it depends. If num1 is less than num2, then we have to swap it. Now we are going to prompt now the student to answer our question. And the user have to answer the question by inputting the question. So we use the input method to get the input from the user. And what we are saying is that what is num1 minus num2? Give us the answer. Now, when you give us the answer, we are going to change it to int, then we assign it to the answer variable. Now we finish. We want to do our actual calculation. So we say, okay, if num1 minus num2 equal to the answer, then that's correct. Just print you are correct, because user entered the answer already. The actual answer is here, num1. Let's say we enter 7 minus 2, it will give me 5. If the user enters 6, 7 minus 2 is 5 equal to 6, no. So this condition will be false. We are not going to print you are correct. Since the condition is false, we are going to say your answer is wrong. Then we're going to print the answer. So we say num1 minus num2 is num1 minus num2 here. So this will allow us to print the original answer. But if the two are the same, then we're going to print you are correct. So this is a two-way. We are using the if-else. If-else. If it's true, you are correct. Else, this condition is false, so I'll say your answer is wrong. Then I'm going to print the actual answer. So I still have num1 minus num2 here. This is not a string. This is the content of finding the difference between the content of num1 and num2. As we said in the first slide, the strings always is in double quotation. So if I have double quotation num1 minus num2 in double quotation, it means I want to print the text, the word num1 minus num2. But if I don't have no double quotation, it means I want to print the content of it and also do arithmetic operation on the content of num1 and num2. So again, what we learn here is two-way. If-else. If the condition here is true, print you are correct. Else, if the condition here is false, print your answer is wrong and give us the correct answer. So again, we also have the multiple alternative if statements. So here we have more than two. If we have two, we use the two-way. If only one, we use the one-way. Now we have a multi-way. So here we are using the grade, at least A, B, C, D, F. So that means 5 different ways. So we can say that if score is greater than or equal to 90, we assign A to the grade. The variable name is grade, we assign A. Else, if score is greater than or equal to 80, B. Else, if score is greater than or equal to 70, then C. Else, if the grade is greater than or equal to 60, D. Else, grade F. Now you can see here we have something like a nested. You can see what we are doing here. We have to be careful with the indent. If else, they are in the same level, so you can see we have these two indents correct. So score greater than or equal to 90, this. else we do this. So you can see here we indent it. So the statement here is for the else, it's not for if. Then after we finish B, we have another else, then we indent for else. Same thing, we have another else here, so we indent this for else here. So this is kind of, it's correct, but it's kind of, if you don't take, you have to be careful with the indentation. So the best way is actually, that's what you write here. This is better. The best way is this, because of there's no much indentation here. So here we say if score is greater than or equal to 90, assign A to grade. Then we have if. So this is like right saying else if score if is 80 greater than or equal to 80B, or if it's greater than or equal to 70C, or if it's greater than or equal to 60 is D. Else, the last section is default. Same here. Else, there's no condition no more. But else, if the condition. So I'm going to write if in one line, then write that expression. So this is the better way because indentation is only once. And all the if up to else, they are all aligned. And also this is the flow chart. So we check our statement, is score greater than or equal to 90? No. Okay, then we go to the next, score greater than or equal to 80? No. Okay, we go next, score greater than or equal to 70? Okay, if it's yes, we print C. If no, we go to next, greater than or equal to 60? Yes, we get D. If no, then the last option is F. We don't even need any condition here no more. Anytime your score is less than 60, then everything is F. Or let's say your score is greater than or equal to 90 is true, then we just print A. Then we skip the rest. So here we're going to trace the if-else statement. Now here we say, suppose your score is 70 and your condition is false. Because if 70 greater than or equal to 70, that's false. So A will not print. Then we check it with the second one. Is 70 greater than or that's false? B will not print. Then we check third one. Is 70 greater than or equal to yes? Then we print C. So if I print C or assign C to grade, the rest below will be skipped. We don't check. This is the reason why it's good to use the if-elif. Now, if I'm using if the condition is true, I'll still check the rest of the if. We have to check all of them. So let's see how we go by. We have 70, the condition was false. That's what we said, condition is false. So we move to the next. 70, yes, 70 greater than or equal to 70 is true. So if that's the case, we assign C to the grade. So grade is C. Now we go we exit the if statement. Since we get the grade is C, we don't need to check the rest. But if we are using if score is greater than or equal to 90A, if score is greater than or equal to 80B, if score is greater than or equal to 70, I'm using only if throughout. Now, if the grade is 8, let's say the grade is 95. So if 95 greater than or equal to 90, the A will print and we assign A to grade. But since we are using if, it's going to check the second one. It's going to check third until the end of it. So that takes long, especially if you have a lot of conditions to check. So it's better we use the if-elif. So we have another example here. This is an example is about Chinese zodiac sign for a given year. So we have 12 months. So the first month is monkey. Let's say January, February is rooster, March is dog, etc. So now we say, let us write a program to find out the Chinese zodiac sign for a given year. The Chinese zodiac sign is based on 12-year cycle, each year being represented by animal, rat, horse, tiger, etc. So here we're going to use the if-elif-else multi-way selection statement. because we can see we have 12 different ways. So we ask the user to enter the year. User enter the year, but we're going to use the modulus operator. So we change the year to int. So as we say, anytime we use the input and we enter the year or any data with input, we are assuming that the input will be string. Then we use the int to change it. Why we are changing it to int? Because we have to use the arithmetic operation to check. So we use the modulus. So we say zodiac year, whatever year we enter, modulus 12. Now, if it's modulus 12, we know the first year, 0 is monkey. So whatever year I enter, if it's modulus 12, because in this case, every 12 years we come back to the beginning again. That's why we're able to use modulus. The first year is, let's say, it's monkey, rooster, dog, all the way to rabbit, etc. Dragon. Let's say dragon is 12. Then the next 13 will be starting from 0 again. So now we have monkey. So we have to modulus 12. If I divide the value by 12, the possible remainder will be from 0 to 11. And that's what represents the year for us. So first one, if it's 0, then it's monkey. If the remainder is 1, it means the second year. So it's rooster, etc. So we do that all the way to the end. Then if it's not any of them, then we print sheep, the last one. The goal here is to understand the syntax. Here, when we look at the question, we are representing the zodiac year with the, so for example, if the year is 0, it should be monkey, 1 is rooster, 2 is dog, or to the 11. So from 0 to 11 means 12, so 12 years. And the question here is a 12-year cycle. So after we reach the 12-year sheep, we start all over with monkey again. So that's why, again, we are using the modulus 12. So these are some of the common errors that we can make in selection statements. Most important is the incorrect indentation, to indent, as we said earlier. Let's say we have radius here, -20. We said that if radius is greater than or equal to 0, then print. We find the area, then we print it. But this print will always print. You can say the print is in the same alignment with the if. So the if doesn't affect the print. So print will always print. Even if the modulus is any value the modulus, if the in this case is modulus -20. So here to print the area is, if there's nothing inside, then it will print nothing. But we are not going to do this calculation because the condition here affects the calculation here, but the print will not affect. So this is the correct way. Since the two statements here affect the if, we indent both. So this means nothing will happen. Is -20 greater than or equal to 0? No, false. So we skip the 2. So indentation is one of the common error in Python, not only for selection statement, but other, especially if you are used to a specific program already before studying the Python. So this is the tip they gave us. If non-modulus still equal to 0, assign true, else false. It's the same as saying that if non-modulus still equal to 0, then assign the EV number to be EV. So again, we have another question, the same concept. You can see our main decisions we're going to make here. This is the condition. If your value is below 18.5, then you are underweight. If it's between 18.5 to 24.9, then you are normal weight. I would say average. Then from 25 to 29.9, you are overweight. And over 30, then you are obese. So you can say that here we want to write a program that will make this decision for us. If the BMI is within these values, then we can see whether it's underweight, normal, overweight, So this, I'm going to use a multi-way. So the question here said we have a body mass index, which is the measure of health on weight. It can be calculated by taking your weight in kilograms and dividing by a square. So we take a person weight, which is in kilogram, then we divide that by the square of his height in meters, and that will give us the BMI. Then the answer we get, we are going to compare with any of these four conditions. If you have to fall between within any of these four conditions, and it can be either underweight, normal, overweight, and obese. So let's see the program. So we need a weight and a height. So the first thing we ask the user using the input method, we tell the user to enter the weight in pounds. Then we change it. Again, we are going to use the value in arithmetic operation. So we change it to float. Then we assign the value to weight variable. We have second value, we ask the user to enter the height. User enter the height. We change it to float and we assign it to a variable name height. Since we are going to convert kilogram with pound, here we make sure that we write down the kilogram per pound is 0.453597, etc. It's a constant value. So which means if I want to change kilogram to pound, I will multiply the kilogram by this. I have kilogram and I want to change it to pound. So if I want to change it to pound, I have to divide. Now, if I want to multiply, let's say if I have pound and I want to change it to kilogram, then I'll multiply the pound by the value here to change it to kilogram. So here we already asked the user to enter the weight and height. So now we want to calculate the BMI. So the BMI, as we said earlier, is the weight. First of all, we change the weight to kilogram and from kilogram to pounds. Actually, we are changing it to kilogram. So weight times kilogram per pound. And then when we change it to kilogram first, so that's what we have, weight in kilogram. Because here we say kilogram per pound will give us this, which means if I have 0.45359237 kilogram, it's equivalent to 1 pound. So if I want to change to kilogram, then I will multiply whatever weight I have in pounds times, that's why here we say prompt the user to enter weight in pounds. So then we enter the weight in pounds. So the pounds times kilogram per pound will give us the weight in kilogram. Then we also find the height in meters. Again, we enter the height in inches. And we said meters per inch is 0.0254. So to find the height in meters, we have to multiply the height in inches times meters per inch. Then we can find the BMI now. So the BMI will be weight in kilogram divided by height in meters squared. So height in meters times height in meters. Because BMI is always the weight divided by height squared. So after that, we have the answer now for the BMI. Now we say, okay, print BMI is whatever value we get. If the value is less than 18.5, remember we say underweight. If it's less than 25, we say normal. If it's less than 30, we say overweight. And then last option is print. So here we are using again multi-way to check because we have, based on the question, we have 4 conditions. Whether it's underweight, normal, overweight, or obese. So if we run this program, first you're going to access to enter so first it tells us to enter the weight in pounds. And we enter weight in pounds. So that's 5. Then we're supposed to get the output weight in pounds. Again, let's run this program. So Let's go back here, and I'm going to run this program once instead of the animation. So here you can see that when we run the program, the user enter 146 and also 70. So by calculations, 46 and 7 by calculations, we saw the BMI will be 6.6 something. And based on the answer here, we say it's underweight because the condition given. Underweight will be less than 18.5. And here we have 6.6. So 6.6 is less than 18.5. So it's underweight. Again, here we enter 46, not 146, 46. So the same thing, we have another program for computing taxes. We know if we are going to compute tax based on your income, you pay different marginal tax rates. So based on whether you're single, married, and your income also. So these are the rates a single person make between the salary here. We show the percentage you pay. So you can see that it changes. For example, if you are married, you have to earn more to have 15%. Single is 8,000. Single is 8,000 to 33,000, but married is 16 to 67 for 15%. And married filing separately also is the same as single. Then head of household, kind of a little bit more than single, but less than the married. So here we have a lot of conditions here, 6 different category of tax payment. So we said here, we can say, okay, if the status is 0, status is 0 means you compute the tax for single. If your status is 1, it means you are married. If your status is 2, it means married but you file separately. Status is 3 means you are head of household. So let's see how this program works. Again, there are so many conditions here. So let's go step by step. First, we import the 6 for our time. We prompt the user to enter the filing status. 0 for single, 1 married, 2, 3, and 2 married separately, and etc. So here the user is going to enter the status. Then also we need the income because we can see different income with different status give us different tax rate. So if I know the income that I make and I know whether my status, married, divorce, etc., then we can compute the tax. But you can see how this condition works. Now we're going to deal with a single first. If the status equal to 0, which means you file as a single, remember if your income is less than or equal to 8350, then your tax will be income tax 0.10. Now if your income go up, again, let's go back to the slides one more second, then we can. What we are doing is the condition here. Let me go back. Is the condition here we have, for example, we are dealing with only single. We have 1, 2, 3, 4, 5, 6. Because now we say that, okay, first we said that single. If your income is less than or equal to 8350, 10% times your income. It's the same single. If your income is between, or we say less than 33,950, because we cut from 0 to 8350 already. So less than 33,950, then you pay 15% times your income. If it's less than 82,250, then you pay 25% times your income. So that's what we are again doing here. So the status is single. If it's 8350 less than or equal to 8350, you pay 10%. So 0.10 times income. If it's less than or equal to 33,950, you first of all going to pay the 10% up to 8350. Then the rest will be 15%. So income minus 8350, 15%. Then if your income is less than or equal to 82,250, The first 10%, 8350. The second 0.15 will be from 339550 to minus 8350. Then the rest is income minus 33,950 times 0.25. And then let's keep going. Then next, we are going to do the status for 1 means, I think 1 is married, 2 is married filing separately, and then 3 is head of household. But yeah, we didn't finish the code here. I left it as exercise. We have to do the same thing here. This time we go to the, again, let's go back one more time. So sorry. So now we did the single, now I'll go here. So I'll say, okay, if your income is less than 16,700, then you pay this times your tax. If it's less than 6,700, then you pay 16,700 of 10%, then the rest income minus 16,700 times 50%, then you keep going. So it's the same repetition as the previous one. And then let's see this code one more time there. That's it. So what, as we said earlier, we get input for, no, this is for the weight. Okay. So this is it for, again, for the task. So first we have the user to enter his status. Status can be either single, married, filing separately, or head of household. So we have the status 0, 1, 2, 3. You have to enter one of those. Then we ask the user for his income, because based on your income, you can either pay 10, 15%, 25%. So here we did only for the single. Status is 0. So less than 8350, 10%. Less than 33,950. First pay 8350, 10%, plus the rest, 10, income minus 8350. Then you keep going. So now if it's 1, and the income, they say between 0 to 17,000, then we say income is less than 17,000, pay 10%. But if income is less than equal to the second option, maybe let's say 50,000, then you put it here. Then we say 17,000, 10% plus your income minus 17,000, you pay the 50%, and you keep going. So this will be the end of our lectures on selection statements. So again, in these lectures, we went through how to, again, use the one-way if statement, two-way if-else, then multi-way if you have more than 2 conditions, if-elif-else. As multi-way, the condition can be as many as we want. And we use the program for A, B, C, D, grade, and F to test the multi-way. Also, we saw the program for calculating tasks, the BMI, whether you are normal weight, obese, overweight, etc. So again, wish everybody the best, and see you in the next lectures. Thank you.